Yo, morning, welcome back to the channel. We're actually on a bit of a Saturday job. So I actually only live 8 doors away, so the traffic was murder this morning. So me and Shawnee are going to be getting on with doing a board change. So this property here is going to have loads and loads of building work done, extensions and so on. So what we're going to be doing is we're going to be putting on another board, which is going to be the main board eventually, but I'll show you because there's stuff from out of the arc ages and I've only seen them in textbooks, but they are still in use here. So me and our new friend Mr. Unicorn, we are going to be getting pretty busy. So first things first, we have got a oh, nearly a broken neck, cup of tea, lovely. So this property has recently been bought, and as you can about to show you, there's a lot of old school adaptations and all sorts of stuff going on. So the house is going to be completely rewired. There is, like I say, two-storey extension. Two-storey, Sean, is it?
Two-storey and a single at the back.
And a single at the back. So that's what's going to be going on. So obviously it's being lived in at the minute. So we are doing one room at a time. So at the minute we've just got one of the front bedrooms that we've got to be wiring in. So the idea is that we're going to be putting new fuse box board up here. That's where we're going to mount it. Now eventually the idea is that there's going to be like a garage through here as such. So we're going to leave all the cables long. We're going to zip tie them up the top, and then we're going to punch it through that way when we're ready for it. Obviously not going to be doing that now because she's going to get pretty wet out there. So the rest of the stuff is all in place, okay? So I'm going to show you down here now. So let's check these bad boys out. So that is all still in use, these things. I've only seen those, like I say, in textbooks. I've not actually physically seen them before. And like I say, they're still in use. It's had loads of different bits and bobs done to it. Also, nice job, nice. Also, the previous Sparkies have a bit of, it's got the twins in, introducing themselves. I'm heater of the night, and I'm heater in the day. So, like that, like that. The other thing is that there's no gas bond here. I mean, the gas meter's here, everything's here, no gas bond on. I find that really weird that that's been missed. So for me, what I'm going to do is I'm going to use that Henley block there, because like I said, I've got to keep everything else going for now. I'm going to run my meter tails up through this bit, up to the top, and then I'm going to come in a bit of rear entry. Ooh. And then, you like that, didn't you, Sean?
Tickled me that.
Ooh, I tickled him. Oh, a bit of rear entry, tickled him. Ooh, cheeky. So we're going to be bringing it through the rear. Because normally I use a meter gland on the bottom, but when it's in the garage, it might be on show. So I don't really want to be damaged too much of the board. I know I could put a blank in it, but that's the plan. So what I'm going to do, stop waffling and get that mounted up. Right, so we have now, I've got Shawnee is
Glamorous assistant.
Glamorous assistant as always. So got the board mounted up. Okay, so like I say, it's all a very temporary thing. It's not permanently staying here. So if, as time goes on, we can punch another hole in here, but I want to try and keep this intact as much as possible. Brought my tails through, and then the idea is, obviously, we're just going to cleat them along here, bring them down, and then down to that way. That's the way I've decided to go, under there. So we've very kindly been given a fan, my world's biggest fan. Got that on because it's actually quite hot under here. So we're just now going to get the all the RCBOs mounted up. Now I've gone with the standard heights on here. You do get the mini versions, but standard height is fine on this one. Now I've only got, I think it's 2 circuits that I'm putting in at the minute, but what I'm going to do is going to get all the RCBOs in for the house anyway. I just think I might as well get them all in. It's a lot easier, and then we can add in as we're going. I'm undecided at the minute on whether I'll bring the cables in through the top end and in, or underneath and in. I'm edging more. Which way, Sean? Top or bottom?
Probably top.
Full. What a fool.
Bottom.
Yeah, that's better. Much better.
I ain't got a clue.
What was he thinking? Yeah, to be honest, I'm not entirely sure. I think I might go from underneath.
Underneath, okay.
Underneath.
I think no matter which one I chose, you would have done the opposite.
Yeah, that's it.
You are literally all my wife.
You know, that's why it works, mate. That's why it works. So that's what the idea is now. So Shawnee, like I say, is being my glamorous assistant. Ooh. Sure you're not ordered too many?
No.
So we're going to get all those mounted in, and then.
That's your lot.
So it's important as well not to use that bad boy when you're putting all those in, because what will happen is the force on that is way too much. So for all your terminals and things like that, it'll actually knacker those up. You've got to use a torque screwdriver to set them all anyway. The only thing I can say, if you pass us the little one, the little drill.
Oh, this.
Yeah, the only thing that I suppose you could argue the case of using that is, obviously it's the wrong bit on there, but is you turn the torque down to 1 and it's literally nothing. You potentially could get away with doing that, but the best way really of doing those is obviously your traditional screwdriver at hand, because you can feel it as well. Makes a massive difference, because the one thing I've noticed is if you slip on the terminals on there, they can be a bit of a pain to sort out. So do it by hand, kids. Don't use the tools on there, and then torque it all up as usual. So that later on I'll show you about the torque settings and stuff on there. But yeah, better get them smashed in now, I'd say. It's a very technical word, isn't it? Smash them in. Right, so the board is, all the RCBOs are in. So the way I go about putting those in, I'll zip tie these and tidy them all up. But I will start generally on a high load and then work my way down. Depending, obviously, as the future goes, we're going to be putting more and more bits and bobs in, but this is the majority of what we need for now, moving forward. But we always put a board on that's too big for the house, because obviously lots of stuff's going on. So for today I've only got 2 circuits that need to be energised. So that is the upstairs lights, which is actually for one of the bedrooms, which I'll show you in a moment, and the radial circuit for that room. So the idea is, what we're going to do here is we're going to be putting radials in on each room, each bedroom, because it allows us then to do a bedroom at a time and keep working our way through. So the upstairs lights we're going to be picking up, obviously, to go on to the next one. That's quite easy anyway. So downstairs there's the lounge over there. So we've also got the cables. I say we, Sean has. I like to say take all the credit. Yeah, it was me. I did all this. Sweet. So we've got the cables in here. So that's actually another radial going in for that lounge, and then we've got the downstairs lights, and this is actually going to be for our smoke alarm circuit, because of, and also in that also goes into the lounge, but they're not chased in yet. It's just that they're in there ready to go. So the reason why in the lounge we've got a carbon monoxide sensor that's going to go in there, because there's going to be a log burner at some stage, so that needs to be all interlinked with everything. And as per building regs, they're going to require everything to be hardwired and linked. Yes, you can use radio links, but why do that when we're going to this extent anyway? So, torque screwdriver, okay? You've all seen this before on the previous videos, I'm sure. So what we've got for on the bottom for all the buzz bar, it's 2.5 newtons. Same on the meter tails, 2.5 newtons on there, and same on here. Now on your main terminals, okay, so then it drops down to 2 newtons, and then on the top of our CBOs it actually goes down to 1.2, which is not a massive amount, but it is what is specified. So next stage for me now is we're going to be stripping these off. We're going to go testing. We might as well do that all together and see if it's all good. Oh, and on that note, right, so we're in the boudoir now. So we're going to do all my dead testing. I haven't energised the board, put the meter tails in, so I'll do all my ZE and stuff like that in a minute. I'll show you all that. So in here, it's been, like I say, it's been rewired. This is the first room in the house to be sorted. So, like I say, we're going to the radial. I can't remember where the last point is here anyway, and don't tell me Sean. Don't tell me Sean knows. So, what should happen, so downstairs I've linked my CPC and my live, basically, linked those together, and obviously that is how we're going to find our greatest resistance. So in theory, my highest resistance will be on the very last one, because obviously resistance gets greater as you're moving along down the line. So what you've always got to do is obviously make sure you null your leads. Now you can, when you're using your 2 leads and you null it there, that's not good enough. You still have to null out this, because this will have a different resistance. Now the easiest way I've found to null these out is you can make a bit of a rig up with a plug and obviously link that out, but I use our band keys and stick them on, and then obviously I bridge those across and then null it out that way. You see, I just find that the easiest way. You've always got your van keys on you anyway. So because it's a 16 amp radial circuit, my maximum permitted ZS is 2.73 at 100%. So realistically, you want to be aiming for your 80% values, but that is our maximum ZS. You do obviously 80% because you've got to take into account like thermal effects, cable installation methods and all that sort of stuff. So 80% is really where you need to be at, but this should be way less than that. So what I would guess, hazard a guess, that this is my first point. I've got 0.15. So I'll go round 0.21. 0.24. So as you can see, the results are gradually getting higher. .33. So we're miles in, which is what we want. 0.33. And then this bad boy up here. 0.37. Okay. So what I would say is that is the last socket on the run as such. Is that right, Sean?
It is.
Ah, happy days. So that's basically shows you. So if you're doing a radial, it's quite easy then to figure out where your last cable is. So obviously now we come back to our test certificate. So you always have to put in your highest results on there. So then we've got to do our insulation resistance test now. Obviously perfect results are 999. Now what you might have on here, because it's all freshly plastered, things like that, that's quite often what happens is you might not achieve 100%, obviously 999 on there, because what happens then is when things are damp still, moisture in the air, obviously it reduces down those readings. That doesn't mean there's anything wrong with it, it just means that the results are obviously a little bit not quite what it's expected. So don't freak out about it, because once it's all completely dry, you'll come back and test it and you'll be back to 999. So that is basically what you really want to be looking for ideally. I've also had it as problems before with USB sockets giving me a bit of weird readings, but that again is nothing to worry about, and it doesn't mean that the sockets are faulty, it's just because they've got USBs in it, which we've clearly got in this room. So let's go downstairs and do our insulation resistance testing. Right, so we're on to insulation resistance testing now. So I generally now all do my testing at 250 volts normally first, and then you bump it up to 500 on a new installation. If it's a old install, I don't really go to 500 volts now because we've got so much sensitive equipment in there. We've got obviously LED drivers and bits and bobs like that. Sorry about that, I had to tell the clients to be quiet. I'm filming, this is really important. Unbelievable. So yeah, so I don't normally do now the 500 volts on existing installations because sometimes I just can't unplug everything. I'm not going to go around and rip all the furniture out and all the rest of it. So that's generally what the deal is. But like I said upstairs, is with the USBs that sometimes you can get it shows a fault, but it's not necessarily a fault. So we'll do our insulation resistance testing as normal. So I've got obviously CPC to my neutral on there, and I've got 999, move it across to my CPC and my live, again 999, and then if we move these now across to here, move that out of the way so you can clearly see. So again, hit test, and it's showing that I've got a fault on it. Okay, now I know that there's not actually a fault on that. It's because of the USBs. Okay, so if I then do it this way and link my live and neutral together and retest, it goes back to my 999. And the reason why that happens is because I'm not measuring a difference between my live and neutral, and that is where, so obviously in those USB sockets, it's going through like resistors and things like that for the USBs. Now if I didn't have USBs on, because like in this one, take the sockets off, put them on to put some Wagers on, retest all that, absolutely fine, there's nothing wrong with them. And that is why, it's because it flags up as this fault. So just double check it, go and do the testing where you're linking your live and neutrals together, and obviously you'll then know that there is nothing wrong with that. We've got nothing plugged into it, and that is basically what the fault is. So that's my insulation resistance testing done on that circuit anyway. And we've just got this lighting one to do, and then we've got some live testing to do, so let's do that now. Right, okay, so we're now onto the lighting circuit. So same deal really, doing our R1 plus R2 testing. So we've linked out down there. Now the loops are brought to the light switch behind me. So my furthest point is actually up here, obviously on the light itself. So our maximum permitted ZS again is 7.28. So we should be miles in that. Same deal with nulling the leads, because we've changed the leads. Now you don't have to do this again if we're going to be keeping these in and boshing around the rest of the house if that was the case, but obviously we're not doing that here. So obviously onto your earthing terminal. We have got 0.39. So we can also make sure that we've got a functional test on your light switch as well, to making sure that that light switch is working, which it is, because I've got no continuity now because the light switch has now gone off. So our highest value obviously on this as it stands now is obviously 0.39. Same deal, we've got to do the insulation resistance test, but if we were then doing, because this is our point number one, if we were then going on to doing the bedrooms and bathrooms and all the rest of it, so on, the resistance will get higher and higher, exactly the same as in the sockets as well. So the general rule is that you don't want to, so if you've got a massive house and you've got downlights everywhere and all the rest of it, you really have then got to start taking into consideration of the length of cable run. So for example, if this is a 5-6 bedroom house and you've got downlights in every single room, you're going to want to put at least 2 lighting circuits in on that, because just for the upstairs, because it's just going to be too much. We've got another job at the minute where it's the same sort of deal which you would have seen on previous videos, where we've got 28 double sockets on one ring. The house is a very big house as it is, and the ZS readings are off the chart, so there's no way of doing anything. So So basically that is what you need to make sure that you're keeping your results nice and low. Like I say, it's nice and perfect. Again, same as usual, putting in your highest results, and then we're back onto the insulation resistance tests, which again, same procedure. We'll do that downstairs, but there shouldn't be any problems with that. Got to make sure the lamps are not in, because obviously with the lamps it will pick up a flag, a fault through there, so you indicate, obviously take the lamps out. Again, with the LEDs downlights, when they are a full sealed unit, again you might not be able to disconnect all those. You're going to need to link your live and neutral and do like a global IR on those, and then that will give you your results. So but yeah, so we'll go downstairs, we'll get that bit all sorted, and then I think what we'll then do is jump back in and do all the live testing, get the RCBOs sorted. Right, so we're going to do the ZE now. So this is a TNS system, so the easiest way to disconnect that is obviously down at the bottom. We've got main earthing terminal here, so we take out that because you don't want any parallel paths for earthing. So on your Mega, we need to set it to max, because you want your maximum earthing. So over here it should give you automatic testing on here. One of the things I like about the Mega, to be honest. Okay, so our ZE is 0.23. So the best thing, the one thing you have to make sure you do now is reinstate that earth before you can do anything else, because you need to basically make, as it stands right now, the property has no path to earth. So I'll do that, and then we need to do our PFC. So. Right, okay, so we're on, so that's all reconnected now. So now we need to get our prospective fault current. So one thing I find about these boards, they're a little bit tight to get your earth clamp in. So it's the same deal on there, but we're switching it across now to basically my ZS. On here, and my prospective fault current is 1.03 kA. So obviously we mark these down in your test sheet. So what was it, 0.23. And again, with having obviously then the parallel path to earth paths, I've actually got a lower reading now, but obviously you need to put in my true ZE on there. And then once that's done, like I say, I can now get on to moving on to doing my live testing, because we can calculate our ZS's. Once we've then inputted all this, we can calculate our ZS values for our sockets and lights, but then we need to do our RCBO testing, which we will do. I always do it at the board now. Now when it used to be the split load RCD boards, it's quite often you'll have a socket circuit on one RCD and a socket circuit on the other RCD, so you could just go around and keep everything all covered. But now it's all changed over to RCBO boards that I always do the full RCD testing at source now. I just find it a lot easier to do it that way, because there's so many of them to rattle through. But obviously today I've only got 2 circuits to test, so it's happy days. So back onto my DB, so 0.23, my prospective fault current is 1.03, so just make sure I've got all that back in there. So we're onto our RCD testing, which is that bad boy. So again, earthing up there, leave that linked in. So we're testing that now at the 1 times, keeping it, because this is a type, what we got here, type A RCBO. So you put those in like that. So energise it. like this. It's a bit awkward now, it's tippy toes. Okay, so that's at the 0 degree cycle, 30.4. And you have to switch it back to 180 degrees to do both cycles of that. So 38.3, and we also need to do our functional test. Obviously pressing the test button on there. So we record our highest result, 38.3, and then it's exactly the same for the lighting, and if you were doing anything else you just rattle all your way through. So you used to have to do it at half times, 1 times, and 5 times the current rating, but obviously with the regs changing now, it's just that 1 times its current rating. But also we test everything to that. But one of the things that quite often people forget to do is do your functional testing. So we'll get that finished off, and then get the board semi-labelled up. Like by means semi-labelled, it's only, I'm not going to go to town on it because I don't know in what order all the different rooms are going to be done, but we need to let people know if they're coming in here and I've got a fault in that room, which circuits are doing what. The rest of them are all just blank. So we'll finish that testing and then jump back in a second. Right, so we are all done. So what I meant by labelling partially is I've just did it that way. Now that'll bug the living daylights out of me. I'm not going to put, you know, additional ones on. When I come back next time there'll be a lot more circuits done, so I'll just rip that off and redo it. Same with my installation date as well, so it's all logged on my certificate when it was done. But I'm not going to put that on because I want to sign it off all in one go. But if it's a case of I really want that signing off now, I'll do it, that's fine. And then I've just zip tied the other cables up for now, just so they're all, you know, neat and they're not going to be flapping about too much. And then we'll take care of this lot at a later date, because I think the mains, just speaking to the client, the mains is probably going to be moved as well out there, so we'll take care of all that then, and then pretty much 90% of that's all going to go. So if you've enjoyed this video, then make sure you give us a thumbs up. If you haven't already subscribed, make sure you hit the link in one of the corners and turn your notifications on. We put plenty of videos on, and I think it's about time I'll get in there. See you later.